Hi, my name is David Zimnicki, and I'm a PhD student at Vanderbilt University, and I work with the Center for Rehabilitation Engineering and Assistive Technologies, or CREATE. And today, I thought we would talk about the marvelous multi-purpose machines that make us move, or our muscles. There are over 600 muscles in the human body that do all sorts of things, like pumping blood through our body, letting us run really fast, and giving us a way to interact with the world. So, if you had to take a guess, how many individual muscles do you think it takes to go on a walk, or to dance, or to send a text message? Well, counting all the big muscles and the little muscles, it takes 94 different muscles to go on a walk, and probably a few more if you had to keep all those dogs from chasing a squirrel. It takes even more to waltz, with 137 different muscles, because in addition to using your lower body to move your feet across the dance floor, you're using your upper body to twist and turn your arms. And finally, how many does it take to send a text? Well, as small as the motion might be, it takes 38 different muscles to send just one text message because of how careful and precise those little finger tapping movements have to be. So it clearly takes a lot of muscles to do all these different activities, but how do we actually control those muscles and move our body? Well, the way we really move our muscles is by using our head. So imagine a dodgeball is coming your way and you want to catch it. How does your body know to lift its arms and to grab the ball? Well, in a split second, your brain sends a command to your body by generating a little electrical signal. And this signal travels from your brain down your spine and towards your muscle group that you want to move. The signal travels through a long chain of neurons, which we commonly call our nerves, and those neurons deliver the electrical signal to your muscle. When the electrical signal reaches your muscle, it responds by contracting and moving your hands into place so you can catch the ball. And all of that happens like that in a fraction of a second. In fact, our reflexes, the ones that help protect us, like when you instinctively pull your hand away from a hot stove, they can be so fast that it happens within less than zero point 0.1 seconds. So, we've talked about how many muscles there are and how we might use them, but now let's talk about how we study them. One way we can study these muscles is through EMGs, which stand for electromyography. And let's break down that word real quick. Electro means the electrical signal from the nerves into the muscles. Myo is Latin for muscle. And graphy is, well, the little line graph that you see on the right side. So you can see here that the EMG device is just this little box that rests on the skin above a muscle. And when the EMG is sitting on that skin, it can read the electrical signals from the muscle and show us what they're doing while you perform an activity, like lifting a weight or running. The different patterns that we read from the EMG can tell us a lot about how hard your muscles are working to move your body. For example, if we see a really busy graph with fast up and down motion, we know the muscle is working really hard because it's receiving tons of powerful electrical signals. But if we only see a really relaxed graph that doesn't have a lot of up and down activity, then we know that the muscle has lower activity right now. Another way we can observe and actually visualize the muscle activity is through ultrasound. And you may have already heard of ultrasound before in a different context, like taking pictures of a baby before they're born. But we can use that same technology to create an image of the muscle as it moves. The ultrasound device sends tiny sound waves into the body and listens for their echoes, and it can interpret those echoes for us visually so we can see the muscle moving without even breaking the skin. Okay, so now we know how we can study these muscles more closely. Let's talk about how they work to move our body and how we can recreate that movement with prostheses. So, imagine you have your arm long and relaxed by your side. But then if you contract or shorten your bicep muscle, it pulls on your forearm and it rotates it upward around your elbow into a curled position. As biomechanists, we study how the human body performs this task, and we analyze the motion of our limbs and the forces in our muscles to better understand the inner workings of the body. The really interesting part is when we take what we know about the human body and begin to recreate limbs for those who have lost theirs. If you think about this prosthetic elbow here, people design motors and sensors inside this device to replace our biological muscles and nerves to allow the user to lift their arm and restore their ability to interact with the world in that way. Studying the body like this and helping people regain their abilities is why I love studying biomechanics.